So let's do number 4. A survey of college students was conducted to see how many go to sporting events on campus. From the 1,365 students that were asked, 863 students said they attended events. Construct a 99% confidence interval for the students that do not attend sporting events. Okay, so let's see. What are we doing here? Are we doing proportion or mean is the question. Okay. Well, let's see. They gave us nothing with mean, right? No standard deviation, but they give us scenarios, right? This is how many people over the how many people. So we're actually doing proportion here as well when it comes to it. So since we're doing proportion, just like the other ones, we need the four numbers to deal with here. So p hat is the number of proportions, so success, right? Now this is what's the tricky part of this question. Let's see if I want to caught a lot of you guys. What are we doing a confidence interval of? We're doing a confidence interval for the people that do not attend sporting events, right? This tells us how many people actually attended sporting events. So therefore, how many people actually did not attend it is the question. We should give us 502, right? The subtraction of those two. So pretty much success in this case is what we're asked is how many people did not attend, the proportion of people that did not attend. So we're actually doing the 502 divided by the 1365 as our p-value itself. That's what the tricky part about this question actually is. So if we do that, our true proportion, p-hat proportion is going to be 0.37. And therefore, failure, right, would be someone that actually does go, again, because of this question asked, do not attend, right, when it comes to it. So it will be 1 minus 0.37 or 0.63. And is 1,365. And since we want a 99% confidence interval, therefore we go over here, that's going to be a different one, right? That's going to be the value of 2.75, oh, sorry, 2.575, 575. So now that we have our four numbers, we can find our margin of error. So it's going to be now 2.575 times the square root of 0.30 times 0.63 divided by 1365. And then once you do this in a calculator, you should get approximately 0.028. Okay. And now we're going to add and subtract it to our p, which is 0.37. So once you add and subtract it, you should get your confidence interval of 0.342 and 0.393 as your confidence interval. Right? And then finally, the interpretation will be, we are, in this case, 99% confident that the population proportion of people, or students, in this case, students that do not attend sporting events is between that number and that number. And that finishes up the problem here. Okay. All right, so now let's go to number 5. So number 5 says, over the years, the weight of men has increased. So I need to update our estimate of the mean so that boats, aircrafts, elevators, and others do not become dangerously overloaded. Using 40 men and having a sample mean of 172.55 pounds with a standard deviation of 26 pounds, construct a 95% confidence interval of the mean of weight of all men. Okay, so from this data, is it safe to say the average weight of men is 185? Okay, or 187.88? Okay. Now, here's a question. Is this a proportion or means one? Well, just go to the question, right? What is it asked the confidence interval of? We're asked to construct a confidence interval of what? Mean. So unlike the other ones, right, where they said proportion, this one literally says mean. So again, the question will tell you exactly what scenario you have to be in. All you have to do on your job is to figure out, the keywords asked of you, right? Straight out asked you to do that. So therefore, this is the first scenario we're actually using this portion, right? Using mean. So I'm using mu, x bar, and now t values. The good news is, notice it's the exact same template here, right? We're going to be plus or minus our margin of error, but now we're going to be using this equation for our margin of error. So now t-scores, right? Because we're dealing with mean. Okay. So for that, this margin of error is a little easier to deal with because there's one square root, all that fun stuff. So first thing off, we got to find s, because that's our equation, what n is, and our t-value, right? So S in this case is standard deviation, so that's giving us to be 26. N is our sample size, so how many people? In this case, 40 men, right? And now to find our t-value, well, we need our alpha. So that's the one thing we actually have to memorize now. So alpha is 1 minus 0.95, right? Remember back to the definition, it's 1 minus the confidence interval. That's going to be 0.05. And degrees of freedom is 1 minus 40, or 38. Oh, sorry, 39. All right, so now we go to our table to find the t-value. Here's 0.05 alpha. Go down to 39 degrees of freedom. And our t-value is 1.685. Okay. All right, so now we have that portion now. We can keep going to find our margin of error. So according to our equation, so again, just pop it up real quick. It is our t-value times s, so 1.685 times our standard deviation, which is 26, all divided by the square root of n, or in this case, 40. Okay. All right, so once we do that, you should get roughly a margin of error of 8.32-ish, approximately. Okay. And then just like the last ones, right, all the other ones, because this is almost identically, now we do our margin of error minus our mean, right? Because again, going back over here, it is x bar minus c, x bar plus c, not s, right? Now notice, we didn't write down what x bar is. So let's go back. What was our mean to begin with? Right there. Sample mean of that. So our mean is 172.55, which means we plus or minus that number to 8.32. So once we do that, we get 164.23-ish. And so we do mu, right? Mean, so it's mu, not p anymore. And if you add it, you should get a roughly 180.87. And that is our confidence interval. So the average weight of men, according to our data, is between 164 and 180 pounds. Okay. So lastly is our interpretation. So we are 95% confident that the population mean this time, right? Population mean of, again, just copy it, weight of all men is between 164 and 180. Okay. And then finally, the last little scenario, right? That's the follow-up question. From the data, is it safe to say the average weight of man is 187? And again, that's also a hard no, right? Because it's not between the numbers we found to be true. Okay. Right, so let's keep going to number 6. Okay. So 6 has two parts. It's two different questions into one. So it says 6 is a simple random sample of birth weights in the United States, has a mean of 4,321 grams with a standard deviation of 500 grams. So A says, using a sample size of 75, so here's our n, right? Sample size of 75. Construct a 95% confidence interval to estimate the population. Again, notice the word, right? So the question really tells you what you want to do, the mean of the data values. So it's exactly what we just did above. So first thing is, we want to find S, which is 500, right? Here's our X bar, right? Because that's our mean. That's what it tells us our sample mean is. Okay. Sample size, in this case, is 75, again, told to us here, right? Okay. And now find our t-value. So t-value, so alpha is going to be 0.05 again, because 1 minus 0.95. And degrees of freedom in this case is going to be 74. So if we go to find our t-value, let's see what we get. So we have 0.05 going down to 74 degrees of freedom, which we don't have. So what's closer? Is 74 closer to 70 or 80? pretty sure everybody said 70, right? So our t-value is going to be 1.667. Okay. All right, so now we now have that there, and we can find our margin of error. 1.667 times our standard deviation of 500 divided by the square root of 75, and we should get a margin of error approximately 115.124-ish. Okay. And now, so that's step one. So now we go to step two to find our confidence interval. So a confidence interval is this number plus that, this number minus that, right? So if you subtract these two numbers, you should get a roughly 4,205.876. And if you add these two numbers, you should get a roughly 4,436.124. Okay. And then finally, interpretation. We are 95% confident that the population proportion mean of birth weights in this case in the U.S. is between there and there. Okay. Now B is identically the same except one little thing. The sample size changes. That is the only difference when it comes to it. So I'm going to skip ahead. So we're going to find our t-value. I'm just going to write this all in for us real quick. So we're going to have a little bit different t-value itself, right, when it comes to it. Alpha is still 0.05, but if you notice, our degree of freedom is 74,999, because that's 1 minus that. But we don't have that on here, right, because it's way too high of a value. So you can either go to the 1,000 or the z, and notice there's pretty much no difference between them when it comes to it. So you could just use the thousands, just in case you're not sure what to use, because, the one before it does arbitrarily nothing to it itself. Okay? So we're going to do that here. So that's the z. This is our t-value respectively, right? So once we multiply this out and then divide by the square root of that number, we actually get a much smaller margin of error. So 3.52. So therefore, once we add and subtract these values, we get something even smaller. So this plus this gives you 4,324.52. That's the top one. And the bottom one, $4,317.48, and there is your confidence interval. Okay. Now, if you're wondering, well, this confidence interval is much closer to each other than it is, and notice the margin of error is drastically different, right? So the key thing, right, like the whole process of this concept of confidence interval is, notice what's the only thing that changed from part A and part B. Hopefully you guys saw the sample size, right? This is 75, this is 75,000. So the whole concept of a confidence interval is, like, here's a scenario according to this question, right? If I have the weights of every single baby born, like I weighed every single baby in the United States at that moment, okay? And if I create a confidence interval, these two numbers would be identically the same, meaning there would be no margin of error because I have every baby in the entire United States at that single time, right? Now we know babies are born pretty much on, a second basis, right? So, after that portion, then we have margin of error because we don't have every single baby in the entire United States anymore. So that's why you want a larger sample, because you want this margin of error to be smaller and smaller and smaller, and therefore you have the true mean always between smaller numbers, right? Notice, this isn't too big of a deal, right? But, we can get even better with that, right? Because if you notice, this margin of error is, 115, and this is only 3 away, right? So that's even better, right, when it comes to it. So that's why when it comes to this type of confidence interval, in this class, you're doing really small samples, right? But if you go into the real world, you'll be doing stuff like this, where that even this is considered like super, really small, relevant to the overall population itself, which is pretty cool when it comes to it, okay? All right, so that's in this video. We'll keep going on the other ones.